Starship isn't just a huge reusable spacecraft. It could one day transform into the best space station ever built, but not the kind we've seen before, like the ISS. Imagine a giant orbital outpost with real artificial gravity, where astronauts can live and work almost as comfortably as they do on Earth. It's a challenge that has puzzled scientists for decades, but for SpaceX, impossible never really means impossible. So, what's the vision behind a gravity Starship station? And how could they actually make it happen? Let's find out in today's episode of Alpha Tech. Under Elon Musk's bold leadership, SpaceX has always strived to turn the seemingly impossible into reality, shaping the future of space exploration. Beyond the philosophy of fail fast, learn fast, they also follow the mindset that if no one has ever done it before, become the first. Leading engineers at NASA and around the world had long dreamed of creating reusable rockets, but major technical and financial barriers kept organizations and companies from pursuing it. For Elon, however, it was different. After the success of Falcon 1, SpaceX pioneered Falcon 9, turning it into the world's first partially reusable rocket and ushering in a new era of cost-efficient space missions. Building on their earlier successes, SpaceX realized that no one had ever created a fully reusable spacecraft. That's how Starship came to life, designed to be the first rocket capable of full reusability, with the potential to carry humanity to Mars. But they didn't stop there. They also launched Starlink, the first global satellite internet network, connecting people everywhere, whether stranded on a remote island or deep in the Amazon jungle. And now, it's no surprise that SpaceX is quietly exploring the concept of a space station with artificial gravity, a bold step toward bringing humanity closer to living permanently in space. And the idea becomes even more feasible when SpaceX plans to use their own vehicle under development, Starship. Currently, Starship is the largest spacecraft in the world. Stacked with the Super Heavy booster, it reaches around 123 meters tall. The upper stage alone measures about 52 meters, which, frankly, isn't yet ideal for turning it into a space station, since most of its interior is occupied by cargo bays and fuel tanks. The perfect candidate here is Starship version 4, which will reach 61 meters in height with a 9-meter diameter, giving it an internal volume of around 3,800 cubic meters. It's expected to debut as early as 2028. With this enormous size, SpaceX could dedicate about 1,000 cubic meters of habitable space for astronauts, making it a true space station. Starship Station would be even more practical than the ISS, whose internal volume is only 935 cubic meters, and it would require just a single launch, avoiding the complex assembly of multiple modules in orbit. With such a vast volume, people started dreaming big. We're talking about a multi-level design, like a vertical apartment building in space. One level could be dedicated to research labs, another for sleeping and hygiene, yet another for growing plants and preparing meals. Add a gym, crew quarters, common areas, and a mission control center. And suddenly, astronauts wouldn't just be surviving in space, they'd be truly living. However, there's an important point to consider. The Starship space station will orbit at around 28,000 kilometers per hour. A vertical layout only makes sense if there's gravity pulling you down. In microgravity, though, concepts like up and down lose their meaning. So if Starship becomes a permanent orbital station, the layout would shift to a horizontal design. Imagine something like a submarine, with long decks stretching from nose to tail. And it gets even crazier. If they find a way to free up the interior of Starship currently occupied by massive fuel tanks, by removing or repurposing them, boom, you unlock an enormous amount of space, around 3,000 cubic meters of interior volume. That's 3 times the size of the ISS. In theory, it could accommodate hundreds of people. Of course, SpaceX isn't crazy enough to cram that many aboard. Realistically, the number would likely be 15 to 30 crew members. However, with that many people on board, you'd need a large gym equipped with multiple machines. As you know, astronauts need to exercise for about 2.5 hours every day to prevent muscle loss and bone density reduction, the main consequences of living in a zero-gravity environment. This relates to how the body adapts. Imagine if you somehow made it to the moon. Because you're used to Earth's higher gravity, you could potentially lift a rock weighing 200 to 260 kilograms. About 441 to 573 pounds, since the moon's gravity is only 1/6 of Earth's. But if you don't keep up your exercise, your body assumes you no longer need that much muscle or bone density and gradually weakens over time. When you finally return to Earth, you could end up weaker than a 7-year-old child. To address this problem, many hypotheses and inventions have been proposed. One of the earliest concepts came from Konstantin Tsiolkovsky in the late 19th century, who envisioned rotating space stations to generate centrifugal force, simulating gravity. By 1929, Hermann Oberth, and later in the 1950s Wernher von Braun, developed ideas for wheel-shaped space stations, similar to the iconic design featured in Arthur C. Clarke's science fiction, classic in 2001, A Space Odyssey. These designs aim to solve the health issues astronauts face in microgravity, such as muscle and bone loss. While no rotating space stations have ever been built, SpaceX sees this as an incredible opportunity, a chance to create one, and potentially set a new standard for future space stations. So, what's the idea here? Instead of relying on a single Starship, the most effective approach would be to connect multiple ships together. Linked via tethers or rotating arms, they could form a spinning structure with a large radius, around 20 to 50 meters, simulating 0.3 to 1 g of artificial gravity, without causing strong Coriolis effects that could lead to nausea. Elon Musk has even touched on this concept in response to a comment. When John Carmack, the founder of id Software, suggested that SpaceX try spinning its Dragon spacecraft to test artificial gravity, Musk replied, "Starship will have a small spin on the way to Mars. Even a tiny gravity vector is better than none." However, several core challenges arise when attempting such spinning motion. First, the spacecraft needs to be quite large to rotate at a reasonable speed to generate sufficient centrifugal force. In general, the smaller the rotation radius, the faster the ship must spin to achieve Earth-like gravity, or 1g. Additionally, as Wired has pointed out, astronauts can experience motion sickness from continuous circular motion. The artificial gravity can also vary between the head and feet, potentially causing other unwanted effects. As astrophysicist Dr. Peter Haig noted in a reply to Musk's tweet, there's an alternative to having a single spacecraft spin around its own axis. Why not send them in pairs and tether them together, he wrote. Can get a long radius and easily simulate Mars gravity that way. To clarify this idea, the concept involves docking two starships nose to nose using an inflatable tunnel and tethers, then spinning them around a common axis to generate centrifugal force. This would allow the crew to experience a sense of gravity similar to living on the inner surface of a rotating structure. To break it down, the idea of connecting two starships nose to nose seems more feasible, since it doesn't require multiple launches or the development of complex docking systems. SpaceX could even test this concept with just two vehicles on the ground, making use of existing control systems. However, the downside is the small radius, which limits the effectiveness and increases the risk of motion sickness. On the other hand, connecting multiple starships together is far more complex, since it would require multiple launches, advanced cable or tunnel docking systems, and careful stabilization while spinning. But the payoff would be much better, offering a more realistic simulation of gravity and greater comfort for the crew. So, which idea do you think is more practical? Drop your thoughts in the comments below. That said, creating artificial gravity by spinning Starship, whether it's two ships tethered nose to nose or multiple ships linked together with cables, comes with one huge challenge: docking. A space station isn't just a sealed habitat. It constantly needs resupply missions for food, scientific equipment, and other essentials. And with a massive spacecraft hosting many crew members, those resupply runs would need to happen even more frequently. But here's the problem. If a Starship structure is spinning continuously to generate centrifugal force, any visiting spacecraft would have to perfectly match that complex rotation to dock safely. Without flawless synchronization of speed and trajectory, docking attempts could end in disaster, causing collisions, damaging the ship, or even destabilizing the entire spinning outpost, putting both the crew and the mission at serious risk. Compared to the International Space Station or China's Tiangong, which remains stationary with fixed docking ports, a spinning Starship system introduces a moving target where the docking point is constantly shifting, making the process far more difficult. One possible solution is to design a non-rotating hub at the center of the Starship structure, providing a stable docking port unaffected by the spin. In a multi-Starship tethered configuration, for instance, a fixed central module could be attached to the rotation axis, allowing visiting spacecraft to dock safely. On top of that, advanced automation, like AI-based navigation and precision laser sensors, could synchronize an incoming spacecraft's trajectory with the rotating structure. SpaceX might also draw on lessons from ISS docking, creating step-by-step protocols and even temporarily slowing the rotation if needed, though that would demand a more complex control system. With these solutions in place, Starship could preserve artificial gravity while still allowing safe docking. All in all, if SpaceX can truly pull off a gravity Starship outpost, astronauts of the future won't need to spend hours every day exercising just to stay healthy. They'll have more time for research, and more importantly, their health and well-being will be far better protected. Now, if you think the Starship space station project is already incredible just because it's massive and can provide artificial gravity, you haven't even heard the best part yet. Let's talk about materials, money, and why this rocket could be the ultimate building block for humanity's very first true home in space. The ISS is built mainly from aluminum. Starship, on the other hand, is made of stainless steel, and that changes everything. Steel is tougher, it shrugs off micrometeoroid impacts, radiation, and the brutal swings in temperature out in space. It resists corrosion, it's easier to repair, and it lasts far longer. And then there's the cost. This is the truly insane part. Elon Musk has said a single Starship launch could cost under $10 million. That's pocket change compared to the ISS, which cost more than $150 billion to build and maintain. So, if one Starship launch is that cheap, why stop at one? Imagine launching 10 of them, linking them together into a massive spinning ring to create artificial gravity. Next comes modularity. If something breaks on your Starship station, say a micrometeoroid puncture, no problem. You can just bring it back to Earth, fix it, and relaunch it. Try doing that with a chunk of the ISS. You can't. This alone is a game changer. Space stations no longer have to be fragile, static giants. They can be dynamic, upgradable, and far less risky. The ISS, a symbol of international cooperation, and one of humanity's greatest technological achievements, has been floating in space for nearly 3 decades. It should have ended in 2016, just 15 years after its main assembly. But there's only one reason it's still alive today: China. They have been secretly developing their own space station for a long time, and in 2021, it launched the first module of Tiangong, a bold declaration to break the world's monopoly on space stations. This forced NASA and its partners to extend the ISS's lifetime, partly to buy more time for science, partly to give commercial companies a chance to build the next generation of space stations, and above all, to counter China's ambition to dominate space. Since then, several companies have joined NASA's program called Commercial Low Earth Orbit Destinations, or CLD. But only 4 were awarded NASA contracts: Axiom Space, Blue Origin, Northrop Grumman, and Voyager Space. Each received between $120 and $160 million under Phase 1 funding. Among them, Axiom's project, the Axiom Station, stands out as both the most feasible and the fastest moving. Why? Because its modules are designed to be launched and attached directly to the ISS. Later, those modules will detach and become an independent space station. Progress has been rapid, but due to several reasons, the first modules won't dock with the ISS until at least 2027, and separation into a fully independent station may not happen until 2028, or even 2030. And yet, Vast Space, a company that wasn't even part of NASA's CLD Phase 1 and didn't receive a single cent of those $100 million contracts, has managed to outpace even Axiom in both progress and speed. Their station, called Haven 1, may only be a prototype module, but it has stunned many with its design, its utilities, its deployment plan, essentially, with everything about it. On September 27th, VAST proudly shared an update on Haven 1 via X, announcing, "Haven demo build and test are complete, and it is now undergoing final integration for launch. Meanwhile, we're moving toward critical systems testing and continuing to build momentum on Haven 1 flight hardware." Alongside the post was a video revealing the module's progress. Even from the unfinished outer structure, The craftsmanship already looks incredibly precise, down to the smallest detail. The footage also showcased key components, including its power systems, batteries, flight computer, and even the thrusters. This stage is considered mid-manufacturing to early integration and testing, coming after major milestones like qualification testing, but before full assembly. Most impressively, VAST remains on track for a launch no earlier than May 2026, a full year ahead of Axiom's station. But from now until liftoff, there's still a long checklist to get through. First, they need to wrap up pressure testing and the remaining structural trials by the end of this year, proving the module can withstand vacuum, pressure, and heavy loads. Then comes critical systems testing between late 2025 and early 2026, covering everything from life support and thermal control to propulsion provided by impulse space and power systems, including solar arrays. Some components, like the payload power module, have already been tested, but the real challenge is integrating them all together. Next, in early 2026, VAST will finish manufacturing and integrating the rest of the hardware. The Haven 1 lab module capable of supporting up to 10 payloads, Starlink connectivity, and RF and video systems from partners AnySignal and TRL-11. At this stage, the whole module must pass vibration and thermal testing at full scale. The final stretch in mid-2026 will bring qualification and environmental trials, acoustic testing to simulate launch noise, electromagnetic compatibility checks, and orbital simulations. Only after that will Haven 1 be integrated with its Falcon 9 launcher, go through joint checks with SpaceX, and secure safety certification from NASA and the FAA. And by April or May 2026, the module will enter pre-launch prep, fueling, final checks, and the countdown to VAST-1, the first crewed mission with 4 astronauts flying aboard Crew Dragon, targeted for late June 2026. If VAST keeps hitting these milestones on time, they're basically lining themselves up for a massive payday in NASA's CLD Phase 2. See, Phase 1 was just about early design studies. But Phase 2, that's the real deal. All about certification and buying services from commercial stations to take over once the ISS retires after 2030. NASA's expected to throw a lot more money on the table, making sure at least 2 or 3 companies get picked. And if we're talking about a $1.5 billion pot split between just a handful of winners, VAST could be looking at $300 to $600 million, maybe even more if NASA decides to reward them for proving themselves with VAST-1. And don't forget, they're already teaming up with SpaceX to launch Haven 1, so you can bet that kind of partnership could give them an extra edge when it comes to NASA's favor. The single module design of Haven 1 is really just a proof of concept. Simple, but powerful. At first glance, many people compare its interior to an Apple store, and that's no coincidence. VAST's interior designer, Peter Russell Clark, is a veteran who spent nearly 2 decades at Apple. His touch gives the module the feel of a true luxury hotel suite in orbit, bright, comfortable, and a world apart from the cluttered utilitarian look of today's ISS modules. Thanks to its robust design, Haven 1 can remain in orbit for several months, up to 2 years, supporting as many as 4 crewed missions, each lasting about 30 days, with a crew of 4 astronauts. What makes it special is the human-centered design. Inside, there's a small science lab capable of supporting microgravity research and even early manufacturing opportunities, things like semiconductors. That means Haven 1 isn't just for government missions, but also for private customers, giving VAST the hands-on experience they need before tackling the much bigger challenge, building a true successor to the ISS if they win NASA's competition. As CEO Max Hayat put it, "Our number one priority is to become a company that actually owns a space station, a company with a station in orbit that has flown people there, kept them for a while, and brought them safely back to Earth. That's really the race we're in." Digging deeper into the layout, Haven 1 measures 4.4 meters in diameter, or 14.7 feet, and offers about 45 cubic meters of habitable volume, roughly the size of a single-deck bus. That's just about 1/8 of the ISS, which boasts 388 cubic meters. The station will ride to orbit aboard a SpaceX Falcon 9, with its first crew following a few months later aboard SpaceX's Crew Dragon. Inside, astronauts will find a wide 1.2-meter or 4-foot dome window, a fold-out communal table, private sleeping quarters for each crew member, and even high-speed internet powered by Starlink. As Hayat explains, it's not designed to be a luxury hotel, but we believe that in any environment, if you can feel more comfortable, rest better, and communicate more easily, you'll work more effectively. Pretty impressive, right? But here's the catch. Haven 1 is really just a demo. The true replacement for the ISS will be Haven 2, and that's on a whole different level. Think of everything you just heard about Haven 1, and then imagine it scaled up across the board. Unlike the single-module Haven 1, Haven 2 is designed as a modular, expandable station, much like the ISS. Construction is slated to begin in 2028, with completion by 2032. At its heart will be the Haven core, a massive 7-meter-wide central module, offering 70 cubic meters of living space, launched on SpaceX's Starship. Surrounding it, 8 identical modules, each around 3.8 to 4.4 meters wide and 16 meters long, will ride aboard Falcon Heavy rockets. When fully assembled, Haven 2 will provide an incredible 1,160 cubic meters of pressurized volume. That's more than the ISS's 932 cubic meters, and nearly 4 times the size of China's Tiangong station, which sits at just 340. Each module links through dual docking ports, making it easy for spacecraft like Crew Dragon to pull up. On top of that, the design incorporates advanced shielding against micrometeoroids and thermal extremes, giving astronauts both safety and comfort. And that's just the structure. Where Haven 2 really raises the bar is in its life support technology. Using SpaceX's recycled CO2 scrubbers, the crew could remain on orbit for up to 720 days with minimal resupply, thanks to highly efficient water and oxygen recycling. Its solar arrays start at 20 kilowatts on the first module and expand to a staggering 86 kilowatts when fully assembled, compared to just 9.8 on Haven 1. Of that, up to 40 kilowatts will be dedicated to powering external experiments, opening the door for cutting-edge science. The station will also feature a state-of-the-art robotic arm for maintenance, a dedicated airlock for spacewalks, and high-speed Starlink connectivity to keep data flowing 24/7. Nearly all systems are US-built, with key contributions from partners like SpaceX and AnySignal, ensuring durability, efficiency, and cost control. And then there's the interior. Inspired by Apple's minimalist design, VAST is using flame-resistant maple finishes, and even a panoramic 360-degree cupola window. It won't just be a research platform, it's also paving the way for space tourism, a place where astronauts and, one day, paying visitors can experience life in orbit like never before. So, here's a quick question. What if you suddenly won a ticket to visit Haven 2 someday in the future? Would you go? Drop your answer in the comments. Now, let's take a look at Axiom's actual progress to see just how far they are behind VAST. A few weeks ago, the Federal Aviation Administration, FAA, officially granted a favorable payload determination for Axiom's first module, the Payload, Power, and Thermal Module. Posting on social media, Axiom Space celebrated, "The Federal Aviation Administration has officially granted a favorable payload determination for our first Axiom station module. Now, all Axiom needs to do is finish the module and prepare it for launch." The original plan was to connect it to the ISS for several years, leveraging the station's support during assembly. With these developments, the question arises, what's the purpose if Axiom intends to detach after attaching just a single module? On Axiom's website, they explain, "The Payload Power Thermal Module berths to the International Space Station and facilitates the transfer of critical infrastructure and payloads." In other words, with the ISS expected to retire not long after, we can see that valuable hardware will be transferred from the station to Axiom's module. The new module will also have significantly more storage capacity than the original HAB1, meaning there's more room for equipment being moved from the ISS. Previously, NASA awarded Axiom a firm fixed price, indefinite delivery, indefinite quantity contract with a maximum potential value, including options, of $140 million. Axiom's contract covers a long-term order with a base phase and an option. It's been a while, and the company is still working on its first module. Looking ahead, there will be 5 modules in total. After the first payload, power, and thermal module comes HAB-1, which will attach once the first module detaches from the ISS. HAB-1 offers 4 crew living quarters and supports research and manufacturing. Next is an airlock module for spacewalks, followed by HAB-2, adding more living space for the crew. Finally comes the research and manufacturing module, which includes space for science and a large observation deck. Despite delays, progress is ongoing. Earlier this year, Axiom successfully completed its first mission simulation for the payload, power, and thermal module.